Now we're going to talk about a pretty cool new tool, something that goes between the map and the reduce phase, called a combiner. Before we do that, let's review how you may have calculated the mean in the last problem. And I don't know exactly what you did, but one thing you may have done is something like this. First, you probably had your mapper go through the data. I should say your mappers go through the data and output key value pairs that looked something like day of week, amount spent. Then, for each day of the week, your reducer probably kept a total of the sum and a count. So actually maybe your value here was the amount of money spent, and then also a 1 to help increment the count. And then you probably would divide the sum by the count. And that looks pretty good. But remember, MapReduce is happening on this whole network of data nodes. Each of these little boxes will pretend as a data node. And your data is spread out across all of these different machines. And now let's think about where each of these 3 steps took place. So we're not going to focus on what happened, but where it happened. Well, for step 1, the mappers were all over the place. There were mappers anywhere there was relevant data. But for any given day, well, the reduction had to happen on a single machine where that reducer was living. And actually, that's enough. We've already exposed a problem. Because if there's a lot of data, even if each individual output was simply a day and a number, depending on the number of records we have, transferring all this data to this machine where the reducer lived, that's a lot of bandwidth. That's going to be a lot of traffic on our network that we don't necessarily want and that it doesn't actually seem like we need to have. So what if we could do some of this reduction locally? What if on each machine, before we send our key value pairs off to be reduced, what if we could do some pre-reduction? And it turns out we can. And that pre-reduction happens with these things called combiners. And before you practice using combiners, let me try and sell you a bit more on their value. So as you know, when you run a MapReduce job, you get some output like this. This is where it's displaying how much mapping has happened and how much reducing. But you get this tracking URL. And if you open that URL in a browser, you get a job page. And that job page looks something like this. And actually, if you scroll down below here, you'll see some more interesting statistics. And in fact, we ran 2 jobs. They were identical jobs, except one implemented combiners. So they were reducing locally as much as possible before shuttling that data off to the machine that held the end reducer. And let's compare the statistics from those 2 jobs, the one with combiners and the one without. So let's compare what happened on these job pages, the one without the combiner versus the one with the combiner. So a lot of stuff is the same. The mappers do the same amount. The input matches the output for without and with. That's as expected. In fact, a lot of things look pretty similar. But where things get really interesting is down here at reduce input records. So the reducers had to handle the whole 4 million records that the mappers outputted when there was no combiner. But when there was a combiner, these 4 million mapped output records got combined into 412 reduced input records, or reducer input records. That's pretty amazing. That's a huge change. And in fact, the reducers had to shuffle far fewer bytes, and for time spent, with the combiner this job took 31 seconds to run, versus without where it took 43. That's a significant difference. So you can really use combiners to improve the efficiency of your MapReduce jobs. And we're going to try that next.